This video is the notes for Learning Target 2 from Unit 2. Learning Target 2 says I can determine if a relation is a function. These notes are going to get glued into your notebook on page 19 after you're done. So when you get this notes page, it's going to look like this. You're going to take these two outer edges and fold them towards the center. And then you want to cut on these dotted lines so that you have a foldable that has 6 doors that open. For these notes, you are going to need a highlighter in addition to your pen or pencil. In the last video, we talked about how we can represent a relation in different ways. Today we're going to be looking at how do I know if that relation is a function. So to start, on page 19, we need to write down the definition of a function. So a function is just a really special kind of relation. A function is a relation where each input has only one output. So that means for each x value, there is only one y value. So when we're looking at all of our different representations for these relations, we're going to look at this being not a function first. So if I'm looking at a table that's not a function, that means one of my x values has 2 different y values. And in this case, we're going to highlight this. It's these guys right here that are the problem. This is not a function because -1 matches up with +2 and -1 matches up with +1. So this is not a function because -1 repeats in the x values. And another way that I can say x values is in the domain. That's why this one is not a function. When I'm looking at a table that is a function, all of my x values are different. There are no repeats in the x values. When we look at a mapping diagram, if a mapping diagram is a function, that means each x maps to only one y. So in this case, each of my x values only has one arrow. That's what we want to look for here. Because each x value has one arrow, I know that means there are no repeats in my domain. When we look at a mapping diagram that is not a function, we are going to have an x value that repeats, or that matches up with 2 y values. So if we look at this -1, -1 matches up to +1, and -1 matches up to +2. So if we have a mapping diagram that's not a function, you'll have an x value with 2 arrows. And in this case, this is not a function because -1 repeats in the domain, or in the x values. When we're looking at a graph, we're looking for the same thing. We want to make sure none of our x values match up with 2 y values. So if I look at a graph that is a function, here are all my x values for this function. None of these x values are repeated. each x value only has 1 point. So I know this is a function because no x values repeat, or no numbers in my domain repeat. When we're looking at a graph that's not a function, I've got an x value here that only has 1 y value, but when I look here, this x value of -1 has a point at +1 and a point at +2. So this is not a function. And we call this test, where we draw that straight line to see if it has 2 points. This is the vertical line test. So this fails the vertical line test. And it fails the vertical line test because -1 repeats in the x values. We have this point right here that's -1, +1, and we have the point -1, +2. We could use the vertical line test on this graph, on this relation. And the vertical line test just says anywhere I draw a vertical line, I'm only touching 1 point on that relation. So this graph passes the vertical line test. Each line only touches 1 point. So glue these notes into page 19. You're going to have to fit them underneath your definition on top, and check the playlist for your next directions.